Network. Network is a collection of autonomous systems. Autonomous means independent systems. Autonomous systems for autonomous system for what? For sharing or not sharing, exchange data and sharing resources. Okay. Now when I say network is a collection of autonomous systems for exchange data and sharing resources, what is data? Information like file, one file or one folder. Now when I say resources, there are two types of resources, isn't there? What are they? One is, what do we call resources? One is devices, products. One is products. Like example, if I say printer, I can share printer. Second one is services. So what will be services will do? Like for example, I have internet connection. So internet connection I can give to my friends. So example, nowadays what is the famous one? Nowadays in mobile you do. So that is sharing services. Correct. Now types of network. How do you classify the network? Types and classification we'll see. Types are, first, when you connect two PCs. What is the what we call that? Two PCs. Point to point is topology. Here we say peer to peer. Point to point correct, but in topology that is peer to peer. This is between two pieces. Right. Second is when you connect within a building. What do you call that network? Local area network. So LAN, if you see, is between or within a building. It may be 10 floors also, but to be called as LAN. 2-3 buildings. 2-3 buildings we call it as campus. So when you have connecting 2-3 buildings within the same location, 2-3 buildings, it's called campus. Campus area network. CAN. CAN means what? Within a campus. Now I want to connect 2-3 buildings, but not within a campus. I want to within a city. Then what we call? MAN. MAN is what? Metropolitan area network. See, this is within a city. Like for example, one office is in Belandur, another office is in MG Road, another office is in Hebal. So you connect these 3 offices. What network we call that? Metropolitan area network. So we call this as within a city. The next it will go within a state, within a country, between cities, between states, or interstate, intercity. What do we call that? What you are saying, right? MAN, CAN. So CAN, MAN, last is WAN. WAN is what? WAN is intercity. Inter means between. Okay. Intercity, between cities, interstate, intercountry, interplanet, Mars and Earth, and then keeps on inter-universe like that. We'll keep on. So this is called wide. This is called types of networks. So how do we classify? Basically physical. Correct. Now I'm going to classify the network based on, this is basically, types is done based on what? Geographical. Right? Geographical only we do it, na? Now I'll see based on the size I will classify. Classification class based on size of the network. Like small size network, what do you call it? What do you classify? We call it a SOHO. What is SOHO? Small office, home office network. This is a network where only one home, no? You are actually connecting one internet connection you are getting and working in a small home. Or they are making in home itself you are running an office. That type of small network you call it as small office, home office, SOHO network. Okay. Next, big network, not so big, medium we can say. The medium network, what we call it as enterprise network. It's also very big. There is other level, very high level. So we say medium. Okay. Enterprise network. This is today, today's topic is this. We are going to study enterprise network infrastructure. So here, what we set an example is MNC companies. So MNC company like Intel, IBM, they all are connected all over the world, right? But what type of network they use, what is the design they follow, what technologies they use, that all are called enterprise network infrastructure. Next we have, after enterprise network we have what? We have okay. Then we have service provider network. Service provider network, if you see, it's a very complex network, very big network, right? This is the highest or complex network in the world. Like example, AT&T, British Telecom Network, BT, Indian networks, Airtel, Reliance, BSNL. These all are very big network, complex network, high-end technologies are will be used. Right? Now directly we cannot study service provider technologies. It's a very complex one. First we'll learn enterprise level. So then in enterprise automatically SOHO will also come. It's not that without SOHO in knowledge technology you cannot study enterprise. But you can easily grasp the SOHO by if you know enterprise level. Okay, so we start. First, enterprise network has so many what do you say, blocks. Okay, I'm going to divide that into, classify into three level blocks. I can say like high categories, right? So 3 blocks will belong to it. The first block is called the CAN, campus area network block. Second is data center. Third is WAN. When you take campus area network, we can actually design campus area in 2 ways: 3-tier or 2-tier. 2-tier or this one collapsed. Data center. What will be there in data center? Devices. Second, services. What services will you do from data center? Okay. And in the WAN, what will be there in WAN? Like for example, different types of WAN I tell you, then we'll go inside. Intranet, extranet, internet, PSTN gateway. Okay. Now, what is the devices we have in a data center? Mainly, what will be the data center? First is servers. Apart from that, servers, data center switches. Right? Router will not be there inside the data center. Outside. You have to go to a router, but get servers, switches, data center switches, and what about load balancer? Server load balancer, two load balancers are there. Network load balancers. Firewall, okay. Storage. In storage, there are important servers will have storage sets, separate devices like NAS, SAN. These are all the storage devices. Clear on this? Now, services what we give. Internet proxy service. File, you know what is file service? Storage. File service. Email. Anything else? Web service. And applications. Anything else? So we can give a lot of services like that, security services, right? Community audio video conferencing, chat, Now what is there in the data center? Sorry, WAN. WAN, if you see, WAN are different types of WAN is there. Intranet, extranet, all are WAN only. Internet and finally nowadays cloud. All are different WAN only, but there are simply differences that I will tell you one way. First, intranet. So when I say intranet, intranet is a WAN but private network. Private WAN, something like head office to branch office, like that. You know, nobody can see this, but WAN. Okay. Extranet is, see, this is private WAN, same organization. For example, IBM head office to IBM branch office. That is intranet. But extranet means private WAN, but different organization. Internet, you know, public. See, internet means, remember, what is internet I told you? Internet is a wire, nothing else. It is huge wires connected all over the world. They laid wires. So that we call it as worldwide wires or worldwide web. www you are writing, na? What do you mean www? World Wide Web. Correct now? All over the world they have put wires. So in that wire you are also going to connect your wire also. So that is called internet connection. So internet means nothing is there, just a wire. So all are, for example, you also connected in that wire, I also connected, you are also in internet, I am also in internet. Understand, no? That's it. Clear on this? Next, PSTN gateway. So what is PSTN gateway? Now I want to go to connect, I want to talk to BSNL. I have a phone like this, you know IP phone, right? I have a phone like this. I am going to call this outside of my company. Inside connecting is intercom. Further we will EPPX system, EPPX server. So I can write down here EPPX server. What is EPPX server? What is the service? Telephony service. What service we are giving? Telephony. That is IP telephony we say. See, IP telephony with the head start. It's a book. IP telephony. Our TCP API. Yeah. So that IP telephony service you have to give. For that we take one server. That server is called what? EPPX. What is EPPX full form? Electronic, private, automatic, branch exchange. Like BSNL is there, no? BSNL is public exchange. We call it as private exchange. Or electronic, or private, automatic, branch exchange. So when you do this connectivity, when you create this IP telephony in your company, what will happen? You will be having a server, EPPX server. EPPX server will be doing routing, call routing within your internal. You are calling from even your intranet also. You are calling the head office to branch office also. The same EPPX server will do the call routing. But you want to call outside of your company, like BSNL, Airtel, then where you will go and connect. So that not public. That is another network called, another WAN network called PSTN cloud. Let me write on the right word. PSTN cloud. Gateway is a device, but network you see is a PSTN cloud network. So this is nothing but your telephone like internet. It's a public platform for all the exchanges. So this is for telephone network, telephony network. You connect to this also, right? Next, cloud. Cloud, you know. What is cloud? Outsourcing data center services. What are different types of cloud is there? Different types of cloud. In the type cloud. Private cloud. Public cloud. Hybrid cloud. Community cloud. Like this, so many clouds. Private cloud means the data center is shared with the data center is taken care by some service provider like Google or Microsoft. But after that, nobody can access your data center. They will make sure that you only can access through intranet, private connect, private WAN. Right? So through internet, nobody can access that server, that system, that services. Now, public cloud means everything is coming through internet. Now you can work in your office also, but you go through public network. Anywhere in the world they can access, like web service. Website is there, right? Company website. Company website, where you put? Private or public? Or company website?
No, the server will be in private and
no, the server has to be in public. How can it be private? You are saying physically. I am saying where you host. Private network, public network.
Public.
Then only public can see that. If you host inside your private network, right? If you don't connect to that internet, that server, then you don't put that internet server IP address, public IP address, nobody can see your website, company website. So that is public, which your services is giving to public, right? Something I am giving to public, something I'm giving to private. So private network is only your internal employees, like HR website, applying leave, seeing how many leaves are pending, that are also website only. But that website is only for internal users. Nobody can see. From public network, public services. So there are two things: private network, public network. So now I am saying mix both. I'll give you the service, but something you put in public, something that is hybrid. Community means I want to do video conferencing for 5,000 users, all employees on video broadcasting. CEO is giving. Now for that you need to go for a huge conferencing system, but invest a lot of money. So what I'll say is, whenever you are going for a high level work, that time you can use this community cloud. Like community hall is there whenever you are married. Every day you are not going to call 2,000 people in your home, and 2,000 people are coming for a function for you. What do you do that time? You book a community hall. Correct. Same way, I want to do a huge service, one yearly once or sometime. That time I go for community cloud. So community cloud is like day wise you can go. Service like number of users wise you can do. Different types of cloud availabilities. Clear on this? Okay. Now I'm going to teach you first how to design a campus area network. Then I'll go data center. Then I'll take last we'll do WAN. All three will do. Okay? We'll start. First, when you go for campus area network, there are 3 layers are there. We say 3-tier architecture. What is these 3 layers? Access layer, distribution layer, and the core layer. Access layer, distribution layer, and the core layer. Collapse core is our second model. I'll teach you that later. First, understand 3-tier architecture. We'll start. I'm going to draw campus area network design. Now, first core layer. Core layer means I'm going to put one core layer, I'm going to put a core switch. This switch, core switch, is the center of your network. So whatever blocks you create, it may be data center block or WAN blocks or any block you create, right? All block has to connect to this center. This is the center of your network. Clear on this? One, two, so I am creating second layer, distribution. So I am going to put distribution switch here. Switch 1, distribution switch 2, distribution switch 3. Next, I am going for access layer. Now, core layer is for one campus. Distribution layer or distribution switch, one switch for one building. In campus design, for every building I'll have one distribution switch. Now every building will have one distribution switch. For example, building 1. distribution switch 1. Understand, na? Then building 2, distribution switch, building 2. Understand? Now every floor I will go for a access switch. Now think like this, 3 floors are there every building. Ground floor, first floor, second floor. Like this. Now for every floor I am going to put one access switch. AW. Right. Now next I am going to have next video. Here. Okay. And one more building is there. Now 3 buildings, 3 distribution switch, and every distribution switch we have a 3 floors access switches. Now let us take like ground floor, first floor, second floor. Now every switch has a function, every layer has a function. So I am going to tell you the layer function now. Okay, first think like this, 3 layers are there I told, right? Let us take this. Okay, 3 layers. The first layer is core layer. Core layer, if you see, what is the function of core layer? Core layer function is fast switching. In core layer, as I told you, everything is going to connect to the core switch. So there, I don't have time for processing and forward finding some function. I don't have time for processing and do some functions. So for that, what I will do, my only concern is, as early as possible, I will send it to the right person who can do the work. That is the core switch or core layer function. Distribution switch, yes. Here I will do all the functions. Example, routing will be done where? Here. Like that, so many functions. What was functions you want to do? You do in which layer? Distribution switch. Sorry, distribution layer. Distribution layer. Now, next, correlate distribution layer, then access layer. Now when I say access layer, what is the function? In this layer only, users are going to connect. What is the function of access layer? User connectivity. Now I have a PC. Where you connect? Access layer. So this is the only user we have in IT. Huh? PC. Correct? I have a telephone, IP phone. Where you connect? Huh? I have a CCTV camera. Where you connect? Camera connected to. Then I have a printer, network printer. Where you connect? Apart from that, anything is there? You know wireless access point? Where you connect? So that is important. So WAP is connected here. So remember, wireless networks are extended of wired network. You write down somewhere. Wireless, very important point. Always don't think wireless is starting from wireless. Okay, there is a wired network. I am extending the wired network. That we call it as wireless LAN. So wireless LAN is extended of wired network. Right, SSID and password you give, connect to the WAP and connect to the switch, and switch will go to. Next, any other survey of the users? You know, access CCTV road, access control system, scanner, RFID scanner. Anything else? RFID scanner. Public announcement system, EAS, and e-ventilation system. These are controllers, pass controller, SVC controller. That will have an Ethernet port, we connect them. Right? In data center, we have a controller. The controller will be connected through Ethernet. So that we can access the controller from sitting in your complete laptop, you can access that. So anything else? IoT. IoT means everything. So everything we are trying to connect to the which layer? Access layer. So this is the 3-tier architecture of campus area network. Okay. Now tell me, you have any doubt in this?
What about the configuration will be there in core switch?
Core switch. Core switch will be, as I told you, fast switching. As early as possible, it will send it. That's it.
What configuration will be there?
Switching.
No, switch is there, right? See, if I want to design this network, probably I will be bring 4 switches. At that time, I will make one switch as a core switch.
So you can't do like that. There are some models are there. You cannot use any switches in core switch. So you have to go to that organization or that vendor. For example, Cisco. Cisco will give 6500 Catalyst. Catalyst is the make and model is 6500. Model Catalyst. 6500, 4500, 39, 3850. This only we can use as these models. Okay. So we have our lab, no? CCL lab. Here. This lab has 30 access switches. Core switch distribution should be 1 lab, 1 crore, 2 crores. One switch. Okay. Understand? So this is something different. There are switches. If you see, but different types of switches are there. Like we call it as fixed switches. Means the ports and management port, your LAN and interfaces, all are fixed. Modular switches means something will be fixed, but something you can actually change it, whatever you want. Modular switches. That is one type of switches. Third method is chassis switches. Chassis switches means what? Everything is only Cisco will give you one chassis, then you need to design from top to bottom, from power supply. What ampere power supply, what watts you want. From there it starts, what card to put. That end, from all hardware, you will configure. That is called what? Chassis switches. Now we have virtual switches, 4. So 4 types: fixed, modular, chassis, virtual. Different type of switches, different type of configurations are there. And different models are there. Top of that, I have iOS also. This is hardware I am telling, right? Then you have iOS version, operating system. Depends on the operating system. 4 types of, we discussed, right? 4 types of operating system. What I told you, 4 types? iOS XR, iOS XE, Nexus OS. So 4 types. Depends on this operating system also commands various. Understand, no? So this is like a huge configuration. Basically Nexus is for data center switches. Rest all we can use for, this is for service provider level. This we use, in that different versions are there. iOS also if we take 12.2 is there. Highest is 15. Is coming, that is highest. Depends on the version also, commands will be. Understand? This is just I'm telling hardware and software. Top of that, what is you want to put, what you want to do using this. I'm telling I want to do only fast switching. Then in the switching, what are technologies are there? You want to study, we are going to study switching technologies, like VLAN, BGP, trunk. That's all you have to talk. VLAN, BGP, trunk, ether channel, port channel. That's all will be configured. Again, I am telling you. Now I told you one design model. Another model is there. That is collapse core. So it depends on what type of design you are doing, what you are deciding, which this device has to do what function. Based on that, we will configure. Technologies are already given. The first day you written, no, switching technologies. That's only you are going to configure. But where to configure depends on your design and the. Understand this? Any other doubts? Next I am going to teach you collapse core. Collapse core, if you see, collapse core, if you see, we have only two layer here. One is aggregation layer, or we say core layer. Some places they say core layer, aggregation layer. Then we have access layer. Here I have only the where we use this, very important question, where we use this type of model, design model. This is used for LAN. So when you go for LAN, I have only one building, correct? LAN is one building. For one building, I don't want to go for core distribution access, I'll go for 2-tier architecture. What I will do, I'll take one core switch, right? I'll convert this core, connect this core switch to a different switches floor wise. This is for the whole building. Every floor I am putting access switches. Correct. Access switches. So this will become my core/distribution layer, or we say aggregation layer, then it is access layer. Now what will happen? Pieces will be connected to end host, right? End host devices will be connected to access switch, then directly it goes to core switch. Now core switch will do both functions, distribution function also, core function also. So we no need to have a 3-tier, we'll go for 2-tier architecture. Understood? Done? Next I'm going to teach you data center. So what will be there in data center? As we already discussed, data center means what will be there?
Devices.
First what means? We have servers. Data center means what? Servers. Now these servers are connected to one switch, that is data center switch. This is nexus. Models are 9K, 7K, 5K, 2K, like that goes. Like that 6500, 4500, 3758 or no, like that. Then we connect this data center switch to our core switch. Core 6 is 3500 catalyst. Correct. So catalyst 6500 is our core switch. Now we are connecting to our data center. When you connect to data center, then we have one database, like a database, like server 1, DB1, database server, like huge server. Lot of data are coming and storing here. Further I am going for a SLB. What is SLB? Server load balancer. What we call this? So load balancing will be. Then I want to connect to a server where I want to locally store something, NAS. It will have a RAID. Network attached storage. What is network attached storage? Had I heard about this?
Yeah.
Okay. NAS means we will be storing in a special server, but it is like not directly connected. DAS is directly connected to storage. NAS is network attached storage. Next is SAN. SAN is storage area network. Here, when I go for a storage area network, the complete networking is completely changing. I am going for a special device called a SAN switch. This is, we call it as multi-director switch, MDS. Here also 9K something is there, MDS, and it is connected to the core switch, but it is totally different special network. I am not creating only one server. If I am taking if I am taking only server, right, that is called the NAS, network attached server, attached storage server. Now this server, I am not, the problem with the server NAS, what you know, when you store, it will take particular time. It will take 1 minute, 2 minutes, but I want a high speed storage, high speed retrieval, like video or online. I want to do online conferencing. Can I go online video? It's possible to do NAS? No. NAS is good for storing backup like that. It will take, when you copy paste 1 MB, 1 GB, it will take 1 minute to copy paste 1 GB. First time. But I want like this to copy 1 GB. Then what you do? You create a special network. SAN is what? Storage area network. NAS is special server. SAN is special network for high speed storage. Understand? So these are the different types of devices we have. So Nexus is a data center switches, and server. What type of servers we have? You know different types of servers. No? Servers, hardware. That is services. Administrative services. What you are telling is administrative services. ADS, DNS, DH. Hardware servers, like I tell you, rack mount, tower mount, blade. 3 types you can write down. Server types. What are they? Rack mount, tower mount, or tower server, or blade server. Blade server means in one chassis we'll have 4 servers like this, 6 servers, 4 servers. This is blade server. Tower means it will be standing like this. It's all a tower. Standing like a tower, you know. Tower server. And rack mount is you can fix in the rack. It's a big server, you fix in the rack. Single. It's not small blades, but it's a huge server, fix in the rack. Rack by rack. So different types of servers are there. Clear on this? Okay. Any doubt in DC? You have to understand? You understand? Next, I am going to teach you what? WAN. So when you see WAN, I am going to divide WAN into 3 parts. First, router. 3 routers. As I told you, everybody has to start from which device? So they connected to core switch. Now, this is okay. So I'll write down like this. This is intranet. This is PSTN cloud. This is internet. Okay, R1, R2, R3. So we call this device as PSTN gateway. This is your default gateway. You want to go up to public network, which interface you will go? This particular interface will be R3 FA0. That interface is your default gateway. To go to outside of your network, to go to private to public. Within your network you want to go R1. Now this is ISP. Who is giving? ISP is that one. ISP means what? Service provider network. That's it. It is not public. Service provider has created the network. This network is service provider network. Now what will be there this side? Clear on this? Next, I am going to, now when you go for public network, I want to create cloud also. Like for example, this is Google Cloud. What I will do, I will go to Google network, Google service provider, and ask him, can you give me a Google data center? So Google can directly connect it. Now see, Google Cloud, Google Data Center, I am putting two types of services. One is private cloud, which is only for me to view, and nobody can see that. Then you have public cloud also. This is given to public. So anybody from the public, they can see. Now, if somebody from public they can come inside my company. Can they come inside my company through this R3? Possible or not? See, this is internet. I am putting public. This is public, right? Now, can they come through R3 or not? To our network. This is our server, right? This is my distribution switch, access switch, and the PC. Correct? So they can come. They can come to server 1. Possible? Through the router. They can come, right? Yeah. So we are going to block them. So now I am going to put security device. Security devices. This is called firewall. Symbol is like this. So when you see this, in this there is the three parts, the three interfaces are there: out, in, DMZ. In this DMZ only, demilitarized zone, DMZ only we will put some servers where you public can access. See, I will create a demilitarized zone, military zone, demilitarized zone. So I will create a demilitarized zone. In that particular zone, I will put some servers where users can come access and go back. But they cannot come to in. In is not allowed. Users can come out to DMZ. DMZ to out is allowed. Out to in is not allowed. Understand? So this is called firewall. So firewall will have three interfaces: in, out, DMZ. So first, what is the purpose of firewall? To block unauthorized access or unauthorized packets, right? So how do I do that? I create three interfaces: in, out, and DMZ. If you don't have DMZ, don't put DMZ. Just keep it out. So out cannot, nobody can. By default, everybody is denied. In firewall, we have least privilege. What is least privilege? By default, everybody is denied. So allow who wants supposed to allow it. Rest all is denied. That is the way firewall works. If you don't configure anything, nobody can go outside out to in. Nobody can go out to in. Now I want to allow somebody out to in, then you have to administrator has to manually get approval from the VP or whoever. Then you need to get approval from them. Then only they can come from out to in. Understand? Now I have one there are so many other devices are there, IPS, all these things that you can study in security. Now I want to think like this. See, there is a user who is working from home. Think like this. I am a user. We call teleworker. Teleworker means what? User who is working from home. Now he want to go to access S1, server 1. So how do you access? He will come through a service provider, ISP to internet, correct? Then he will come to this, but firewall will block, not allowed. So what we will do, we will create something called a server called VPN concentrator or VPN server. What VPN server will do, a VPN concentrator will do, we will install one software here, VPN client. Now it is going to create a tunnel between, actually through this, I am not drawing like that, but unnecessary disturb signal. So tunnel is created. This is called a VPN tunnel, or we call protocol is GRE tunnel will create. So inside the tunnel, the data will travel. tunnel is established between your PC and the VPN server. Inside the tunnel, your data is traveling. So this is one technology used to make VPN. Another method is, after this tunneling is established, plus I will do encryption also. So tunneling, you can write a breakdown like this. Public network. I have a public network. I want to make private network, correct? Internet is a public network. So what I am going to do, I take this public network, I'll first establish a tunnel, plus I will do encryption of the data. Now I am going to send the same thing in public network. Though I send it in public network, because of these two, tunnel protocol is GRE, encryption protocol is RSA, for example, right? After doing this thing, what will happen? Though I am sending in public network this packet, this will act like a virtual private network. Understand? What is VPN? What is VPN? I am going to send a data in public network by doing tunneling and encapsulation. So tunneling and encryption, then that traffic will act like a virtual network. Nobody can touch and see. Given the attacks, you have to break the tunnel encapsulation. After breaking the tunnel encapsulation, they have to decrypt the data. This too is possibly very difficult to do it. Understand? Clear on this? Any doubt? Clear or any doubt is the last? You can draw this diagram, then we'll go to next. Clear? So what we studied now? Enterprise network infrastructure. Now in this, sorry, in this now we have seen first CAN, campus area network. There are two types of design is there. Tier 2 tier. Then we understand data center. In data center, what will be there?
Devices and services.
Okay. Data center, what will be there?
Devices and services.
We will have load balancers, storage,
Firewall, switches.
firewall. Okay. Why we put firewall in data center? Why we put firewall here? This is data center, right? Why we put firewall here? We put firewall also. Why we put here? Because nowadays something called BYOD is coming. What is BYOD? So now I don't have control on who will come in and connect my access switch through wireless wire. So how do I protect my data centers? So I'll put one more security in data centers. That's why firewall also comes in our data center also. And we have something called host based firewall, right? Host based firewall, IPS. You know HIPS host based firewall intrusion prevention system. That is installed in your PC, like Windows firewall. No? That is also there, but I'm talking about a dedicated appliance. It's called perimeter. Perimeter security is different. Endpoint security is different. There are different types of security in there. Perimeter security is when you're entering itself, you're stopping. Endpoint security is when you reaches the device, I'm protecting in the device. But I am talking about perimeter level security. Firewall sits in perimeter. Entering itself, like I put where I put there. Entering in the WAN itself, I stop, right? I'm not saying allow them and finally I stop in server. I want to stop in the perimeter itself. Somebody unknown people are coming in your flat. You stop in the gate or you will allow in the kitchen and stop. When you once allow in the kitchen, then don't touch my food, you say. So you want to stop in the gate itself. That is perimeter security. Anyhow, once you come and enter house also will stop. It's different, but levels of security. This is called defense in depth. We'll see later when it comes to security cases. Now, clear on this point?
Yeah.
Any other doubts you have? Okay, let us start next topic. So this is we finished enterprise network infrastructure. Next we are going to study. Okay, let us start. Let us go through the presentation once. So let's see anything you are not able to understand in presentation also. You understand this? See anything you have doubts also. Same thing in different whatever we saw, right?
What is server form?
Now, data center server form, the difference I tell you. Server form is basically only for IT related. Data center is for the whole company. Whole company data is stored there. It's not only IT servers like your HVAC, AC condition, AC access control, CCTV. Apart from IT, the whole other systems also we are storing in the data center, enterprise level. Server form is for a particular project, 2 servers will come. For particular testing project, 2 servers will come. That will keep it local in our campus itself. Enterprise network in the enterprise data center will keep centrally one place or will outsource data center. Outsource to cloud. Enterprise will go to cloud. See, that's why I mentioned here cloud. It may go to cloud also. But this local form, server form, that we use for our day-to-day purpose. We will go change, add, delete. It's like every company will have their own server form inside their campus. That is only for engineers to use it. Like I want to use some server, I need some server. That is server form. I keep some servers, 10 servers on one rack, and I'll use that for my daily testing purpose or practicing purpose, simulated purpose. So for that type of server form, that type of servers we call it as server forms. But for company services we are giving, that comes data center. This is not for company, this is for project. Clear on this? Any other doubt? Now see, this is 2 tier, correct? Intranet They are connected to routers going to service provider, then internet. This is they are going for redundancy. If one fails, other will work. Understand this?
Yeah.
Can you have this? I just send. I forward on you. Okay.
Yeah. You're already.
Huh?
You're already done.
Okay. Next we will start. Wireless access point. The two types of wireless access point design is there. One is autonomous mode, and one is thin client mode. Okay. Now before going to that, there is other one more high level is there. I will start like this because you are wireless mode, so I will tell you. One is ad hoc mode, right? Then we have infrastructure mode. The infrastructure mode has two modes: autonomous mode and the thin client mode. Then we have a cloud lines. Cloud is something management is done in cloud. Infrastructure only it comes, but we keep it like that. Meraki, you know Meraki? You heard about Meraki? Oh, that is cloud only. Cloud lines. Right. Now, autonomous mode, wireless access points are connected to access switch. There is no controller, nothing. You have to manually go to every access point and configure the SSID, passwords, everything. If you have four access points, okay. But if it's more than 10 access points, it's recommended to go to controller. When I say controller, WLC we say, wireless LAN controller. The controller actually what it does, it actually do the configuration. Instead of you are removing the access point for every device, you going to ceiling and removing the access point, connecting a console cable and configuring the access point is autonomous mode. Now I have 100 access points. All are fixed in the ceiling. If some problem, every time I cannot go and remove the controller access point and manually configure. It's a tedious job. So we are to do that, to avoid these problems, what we do, we create buy one controller. What this controller will do, this controller will push or configure all the access point configurations. Now you log into only where, as an administrator, you log into this controller. Admin will log into this controller. Then the controller will push the configurations to the access points. Like WAP. How many WAPs are there? No? They'll log in and you can configure. Understand? This is called what? Thin client mode. Why we say thin client? The wireless access point is client, controller is server client architecture. So the client is no much configuration in the client, right? It must be having PoE, you know PoE? Power on Ethernet. PoE enabled to WAP and connect to the switch. That's it. Nothing else. Rest all will automatically happen. You are not going to do much work in client side. That's why we say thin client. Thick means lot of work is thin client. Understand? Now all configuration is done in the server side. The server will push the configuration to the clients. Client means WAPs. Any doubt? Now this is the point. I have a wireless access point. Then they are connected to controller. Controller connected to WCS, NMS, like that. So management systems. Understand controllers? So one controller cannot handle everybody, right? So we create multiple controllers. Understand? Same point. Core distribution access. Okay, cloud I told you already. You know, right? Infrastructure as a service, platform as a service. You study. Any doubt? Okay. Same thing. Same thing they explain. Let's see this. What is this? Public cloud, private cloud, hybrid cloud. Community cloud means what? Shared by several organizations supporting specific community. Private cloud. Virtual private cloud, cloud services that simulate the private cloud experience in the public cloud infrastructure. So how do you do that? Virtual private cloud.
Will be there.
We run VPN, no? VPN. So like one example. So you feel like you are working in private, actually physically it is in public. It is a virtual private cloud. Right? Next is collapse core, 3-tier architecture. Yeah, see this is 3-tier. Right? Understanding? Why we put two switches? Not good. Redundancy. Balancing also can do, but main is high availability. High availability is like design. This is collapse core. Only two distribution switch, a core switch, access switch. Clear? Now we'll go to topology.
Can you go? These are all the devices that we mentioned.
Let's see the switches now. You want to see the access switch? I'll show you. I have one 3D software. You can see exactly all the switches. Cisco has developed this. Easy for teach. For teaching purpose, for CC data center, no? I use this. Catalyst switches, I'll show you. Which one you want to see? 6500, 4500, 3740. Which one you want to see? 65. Now, next we are going to study topology. So when you see topology, what is topology? Okay. See, this is firewall, ASA. You can connect ASA also in firewall also in this. So all are called blades, you know. We say modules here. All are called modules. In the slots, empty slots will be there. I can put modules. For example, power supply I want to see 6000 power. This is power supply. See, JC they give, then they tell you to design how you want. However you want, based on the number of cards, line cards, you know, line cards, firewall card, IPS card. Based on that, you say the power supply, how much it can support. You have to give the right power supply. Otherwise, it will not work. Overheated will happen. Understand, no? And we have a supervisor engine. And I'll show you main things I'm showing you, okay? I'm not doing everything. Thing is difficult. Soup, S-U-O-P will say, soup. Soup. Power supply is very modern RAM switches, ASA. 8. Okay, now if you see this, Soup. Okay, this is supervisor. So this is the one brain of the chassis. First concept, right? Then brain of the chassis. We put two soup, one soup and another soup, two brains. This is brain of the chassis. So this supervisor engine will have a links, console port. We connect the console cable and configure. Okay, this is the configuration part, where how you go inside the device. Then we have management also. We can configure this. Okay. So Highland 10 GB uplink they are given for two switches to connect. Okay. Two switches they do communication. We saw that this diagram is two switches. That's why we use this uplink ports. Understand this?
Yeah.
This is supervisor engine. Then I'll show you line cards. Line cards are what? Your sparse Ethernet. For example, you want to see 10 gig cards. You seen 10 gig cards? I'll show you. 10 gigabit card.
Here, they do fiber optic cable.
Fiber, yes. SFP. We use something called SFP. From the SFP, you can use fiber optic. See, we have FC, fiber channel, FCOE, fiber channel over Ethernet. You can use Ethernet cable also. Different technologies are there. So, fiber optic cable or Ethernet cable, whichever you like. Okay? This is the two options they are given. FC, FCOE, and and wireless. I'll show you. This is WSM, no? This is wireless. Wireless controller. They'll tell you what is this controller, model controller, and how many it will support. 500 access points config. Okay, 10,000 users it will manage. Okay, so 500 access points if you have in your whole campus, you can use this, connect this, put this model in the core switch, then you can control the. Clear on this?
From the controller, we are controlling the access.
So you log into this controller and it will show you discover all the access points, location wise. You have to give the map. First, controller will ask the blueprint of your company. Then you give the map. Then it will discover, or you need to manually do that, which access point sits where. All these things you configure. Then you start discovering. You use your MAC address or you have to find out which MAC sits where. And once this all basic setup is done, next time onwards, you just go to the controller and say, okay, now SSID change it. It will change all the 500. You don't need to go to every login. It's a centralized management of the wireless. It's not only access point, even your spectrum. What we call, if your rogue access point is connecting, hacker is connecting, detection, and the mobility from one building to another building you are going, but access must not fail. So many things are there. It all comes in this control. And see, mentioned here clearly, efficient roaming, simultaneous high density, efficient roaming. Roaming means what? The mobility. You go into one location, another location, must not. If you are seeing something, the application must not fail. That is good mobility design. That's all are there. So radian, how many spectrums you create, all this can be taken.
From controller to access point, we need to have a cable, right?
Controller, for example, in this case, our topology, core switch will have a controller, WSM, SM. The core switch will connect to distribution switch. And the distribution switch will connect to access switch. From access switch, it will be connected to LAN. Not directly, through the physical connection.
Controller to, we need to go for a switch.
Distribution switch. This controller is in core switch, not open. Core switch I am saying. No? From that go distribution switch to access switch to LAN. So like that. You can directly also connect. You can take controller directly connect one LAN. But how many WAPs you can connect it directly to? Only 4 ports will be there. I don't know how many ports are there. How many ports are there? You don't know, right?
Yeah, okay.
Clear now? Any other doubts? I'll show you something like one controller. 4 ports will be WXC. I was using this WXC 2006 Cisco controller. many ports are there?
Anyway,
Something 3 ports are there and 1 port. So 3 devices will connect. But for example, 500 means how many will connect? Actually, if you see our this one, no, this example, we'll be not having any port here. Actually, you cannot directly connect to controller. Everything has to go through distribution and systems. This is the management tool. So the devices physically connected to. You can access this through the chassis. It's console key. See, this is the supervisor. This is the line cards. Fiber. In the doubt? Okay. Something like talking on fiber channel coaxial cable digital optical link. These are all connectivity part. Do this storage. Sand. Okay. Next we are going to study topology. Okay. Before going to topology, tell me if you have any doubts in this part. Okay. Now topology means what? What is topology?
Connecting a network in an organized way.
Connecting a network in a
Organized.
organized way. That is structured cabling. Structured network. What is topology? You know topology diagram? What is that?
How the network is
So topology means physical map of the network. Map of the network, not physical. I can say map of the network. Now, how do you classify a topology? Two types of topology. One is physical topology. Second is logical topology. Physical topology will tell you wire details, which port connected to what, like that. Right? Physical topology will tell you the wire details. Logical topology will talk about the. We are not going to understand which port connected where, which cable is using that. We are not going to see in logical topology. But logical topology is used for data flow. I want to understand from where to where my data is flowing, how it is flowing, right? The flow of the data. Then I use what topology? Logical topology. So I'm going to teach you types of topologies. First what? Bus, ring, star, hybrid, mesh. These all are LAN topologies. WAN, if you see, we said no, point to point, point to multi-point. In point to multi-point, again 3 cables are there. Hub and spoke, partial mesh, fully mesh. One by one we'll see. Now what I'm going to teach you in these two things. What are two things? Physically how it is connected and logically how the data flow happens. Every topology you have to understand. Okay, let's start one by one. First, draw this diagram and explain you the data flow. Physically you understand there is a device called terminator. I can go ground the cable. The cable is coaxial cable. The connector is BNC connector. And what is this both sides is doing? You are grounding one side you are terminator. That device is called terminator. Okay, first PC1 is sending data to PC3. This is the scenario. Okay, what will happen? First data goes to the connector. It's like a voltage, right? How voltage travels every side it will all sides will go. Right? Now what ground will do? Data will be grounded, destroyed. Terminator will kill the data. Why we are grounding or killing the data? Because there is something called bounce back issue, bounce back problem. Like echo, it hits and comes back, right? Unnecessarily confused. So better you kill the packet which is going out of the end of the network. So you correct ground it or kill it. Now when it reaches this side, who is sending the data? Who is receiving the data? Huh? Everyone will get the data, but everybody will receive. I'm sending a letter to you. It's not in your name. You receive the letter. I'm sending a letter. It's not in your name. You receive the letter. You detect and discard. Okay, see like this. So I am sending. Only PC3 is going to receive and reply. Rest all is. Understand this point? Now who is replying? You reply stars. Again same thing. Others also receives, but they say, boss, I am not the receiver, so I detect and discard. Only PC1 will receive and reply. This is the way communication happens, right? Understand data flow? Very important, because same way switch also works. This is the same method switch also works. That's why I'm teaching this. Hello? What happened? Where are you? No, madam. That's 10 to 1. So where are you? So you got up now only. Okay, voice is. I am available next week. You are coming now. Can you come and register today? Okay. No problem. So come at come at 2 o'clock Saturday if you're coming next week. Hmm? Give me a call and confirm me. Okay. So uh, see, there are two things you can join. You can join for security class, CCNA security class if you want to join. Okay. July 14th I am starting on security class. So July 14th 2 to 6 I am starting. You can join in that class. Yeah, July 14th is what? Now 7 you are telling, na? That is CCNA security class. And this one, this, security plus, if you don't want to join, leave it. Join for CCNA security class. I am starting on July 14th, next Saturday. This is what next Saturday. No, Saturday, Sunday. Saturday, Sunday. Okay. Okay, fine. Take care. Bye. That? Any doubt? This is the connectors. BNC connector. This is still used in Navy. Because if you go for this type of connectors, RJ45, it will rust. It will rust. So difficult for to maintain that. So this is like any rain, water. You know, go cable, na? Cable TV. They also use same thing. Because any rain, nothing happens. This connector and this cable. So BNC connector is and coaxial cable is good for outer conditions.
What is the expansion of that BNS?
British naval connector. When they invented ship, for ship, Navy, British naval connector. For Navy they developed. I'm saying, still Navy. I was taking to Navy students. I was attending the Navy, our Indian Navy. I was taking classes in Gurgaon, Delhi. That time they said we are using this one. Because this is the only connector will not get rusted in sea water. The stall will get rusted. Understood, no? They go for copper, pure copper connector. So never get rusted. Clear? Yeah, this is our ring next. Okay. Now next what we are going to study, how the flow happens in this. Basically, 2 Ethernet card will be connecting 2 Ethernet card will form a ring. Every host will have 2 Ethernet cards. You connect like this, it become a ring. Correct, na? After this, what happens? There will be one stream of packets, like when you go to airport, you'll have something called baggage conveyor. So that will be one day will be keep on roaming. We call this as a special stream of bits in this very fast, millions of seconds, millions of millions of repetitions per second, very fast roaming. Now whoever want to send data, they will request that guy. That guy is called beacon. The conveyor is called what? Beacon. So I'll request him, and the PC is requesting, for example, he will give one token. Request for token, he will get a token. Once PC1 gets the token, he can use the stream or is a beacon. He can use the beacon to transport the data. So now they put the data, whatever want to put, they send it to client 2, right? So they put it in this, then this guy will deliver and come back next round, deliver, next one deliver. Once the delivery is done, whatever you want to send, you send, you receive, whatever you receive, then you give back the token back to the beacon. But now the beacon will hold the token and roaming again. Whoever asks request for token again, he will use the token and they can use the, like bank we go, they give token to you. So whenever you have hold the token, you can, that time your time comes now, you can use that service based on the token, like that, same thing. That's why we call this as a token ring. So every customer will get a token. Based on the token, they are allowed to use the service. Correct? So allowed to use the media. Okay, I was trying to call her only. She's saying she's sleeping. My student. No, call her. So next week she'll join. CCNA security. Next week I'm starting CCNA security. Now, what is the so any doubt in this? I generally say pizza guy. Who's carrying? Pizza guy is roaming. So blue box is roaming. Who want to stop the pizza guy? I want to send, he'll put it and deliver and come back like that. Or conveyor belt example. You understand how you want. So what is the difference in, what is the difficulty or disadvantages in bus and rail topology? Huh?
Bandwidth will be wasted.
Bandwidth, what bandwidth?
Like, it will go to the SD-WAN like.
See, if one place cable got cut, what will happen? Whole network will go down. Nobody can communicate to no one. And where it got cut, find out difficulty. Where it got cut, how do you find out? You cannot check each and every value. For example, you go for coaxial cable, it can go up to half kilometer without repeater. Now, I have seen, I was working in this one, colleges, no? In old days, we used to have a lab, computer lab, big room. In the room, 50 computers will be there, 40 students will sit there, 40 computers will be there. All are connected through BNC cable, backside connected to BNC connected. Now, the whole network is down. So nobody can access anything. All network is down. Now, where I will check where it got cut? So, almost half a kilometer. Cable. Where will check? Very difficult to find out where it got cut. So, what is the solution for this? One is, if one place cable got cut, whole network will go down. Second problem is, even it cuts, troubleshooting also very difficult. Where it got, we don't know. Correct now? Understood? Now, the solution is star topology. What we did in star topology, we made one central device. We made one central device called a hub. These all are called spokes. Now, cycle wheel, you know, cycle wheel? We call spokes, no? What is the central one which is connecting the spokes? Hub. Same way, the same terminology. Hub and spoke. Lot of places we use this. The central device is hub, all spokes. Now, same scenario. For example, this computer is failing. This cable is going to cut. Now, what will happen in this? In this scenario, what will happen? Only that PC will lose the connection. Others can still have communication with the network. Correct? Only this PC cannot communicate. Correct? No? Now this PC want to access this PC is possible. One problem solved. Is it to troubleshoot? Yeah, I know this cable is not a problem. I can change the cable. This troubleshoot also. Good enough. But what is the problem in this topology? Disadvantage in this topology.
If up close or down.
Technically called single point of failure. What do we call this? If this point fails, the whole topology goes down. So now we need to overcome this problem, this disadvantage. What do you do? Huh? We will go for next level. The next topology is hybrid. Well, hybrid is very simple. Take more than one topology, right? Take more than one topology and create a redundancy like this. Okay, I made a ring also. So this is now star plus ring, or we call hybrid. So more than one topology I am connecting. Then I am creating hybrid topology. Hybrid is nothing but more than one, like this. Mix ring, star, bus, everything we mix. We create one network. That topology is called what? Why we are creating like this? Redundancy purpose, to avoid single point of failure. Understand this? Hybrid topology. Clear on this? Next, after hybrid, we have. Now, some people say, see, at any cost, I don't want to lose the network. I want high availability. For high availability, what topology we will recommend? Mesh topology. What is the definition for mesh topology? Every host is directly connected to other host in the network. It is like this. 4, na? Everybody have 4 NIC. See that? This is the definition, theory, conceptual diagram. We cannot do this like this. But we saw some example in theory tier 2 tier, na? That is real topology. But this is the conceptual diagram. What they say maximum is this. You want maximum? You can go like this. You have 100 computers, create 100 NIC by 100 NIC, 100 network interface card, 100 cables you create. Put everybody directly connected. Then only it is mesh.
What is the motherboard support?
You have to buy cards, external cards. I'm telling you, server level case. It is not. I'm not talking about this. Where we'll use. I mentioned that airport, banking, ATM, that type of people where they are mission critical networks. Not for end users. See, end user, if the switch fails, only 25 people are not going to get connection. No. They can wait for 1 or 2 days. One day also they can wait. Or 1 hour they can wait. The admin will change it to new switch. 1 hour they can wait. But this is something like your ATM server. Your ATM server is there for ICC ATM server. Somebody is swiping the ATM card. Now the server is failed. Now why it failed? Rat bite the wire. If you say like this, they will accept. Think. Thousands, millions of people are accessing. Fail. So you need to have a redundant, physical redundancy, logical redundancy, server redundancy. But physical redundancy, this is mesh topology. Clear on this?
Yeah.
Next we will go to WAN. WAN, you know, point to point, point to multi-point. In point to multi-point, we have 3 types: hub and spoke, partial mesh, fully mesh. I'll explain one by one. Point to point is simply straight connection, head office to branch office. This is point to point. Point to Multi-fine means one head office, for example, head office, branch office, R1, R2, R3, R4. Okay. Now R1 wants to go to R2 or R2 want to go to R3. How it will go? Now this is hub. These are spokes.
It has to come to R1 after that.
Yes, R1 then R3. This is hub and spoke. So branch offices want to communicate, intercommunication. They have to go via head office. That is hub and spoke. Now when you go to a service provider and they will, if you ask them, can you give us interbranch connectivity? What the branch manager of this ISP will ask is, what type of connectivity topology you want? Hub and spoke or fully mesh or partial mesh? Then you have to tell him, I want hub and spoke. If you give hub and spoke, what will happen? Interbranch connectivity will be through hub. Okay? Whatever router you decide as hub, through that hub router will all the interbranch communication will happen. So you can put access list, you can block them. You don't want interbranch communication. Understand? No. Right. Generally they do this for security purpose. No, I want to communicate between these two people. A lot of data transfer is happening between them. Unnecessary, I don't want to load my head office router. So I am going to create another one more value, 2 MB, between my R2 to R3 branch. Now the traffic from R4 to R3, they have to go through head office. But traffic from R2 to R3, it will directly come. It will not go through head office. So then this becomes partial mesh. Now I say every branch can directly interconnect with them. Branches are interconnected directly. Now every branch is directly interconnected. So they will not come to head office until there is a traffic goes to head office. Then only the packet will go to head office router. Then that type of communication is called what? Fully mesh. Understand this? Hub and spoke. All branch service router communication will happen through head office router. That means hub router. Partial mesh, whichever branch, interbranch communication you want to have separate connectivity, you can give that. That is partial mesh. Fully mesh, all interbranch communication happens directly. Only head office traffic will go to head office router. Clear on this? So they will ask you when you go for a service provider and tell him to give WAN connection, intranet, no? I want intranet connection between 4 branches, head office and branch office. They will ask you, first question is this, what we will call. Clear? Okay. Now you want to continue or will stop? This is cables and connectors. Then we have troubleshooting methods. And then next we will start IPv4 actually. You have to start IPv4. So IPv4 will be big topic. These are small topics. Troubleshooting IPs that we can do tomorrow. 10 minutes. Not tomorrow, next week. Next week Saturday. 10 minutes it will take. Not much time. But IPv4 will take 2 hours. Clear? So this we can take on Saturday. Start from media cables, ports and connectors. Then troubleshooting methods and that will take 10-15 minutes. We'll finish it. Then we'll start IP4. So IP4 is a subnetting. Basics we have to study first. Then I'll teach you subnetting. Then IPv6. Then fundamental we are finishing. Then we have to learn. Maybe next week we'll be finishing the fundamentals. Fundamentals. Next week you have to bring the laptop. So I will teach you. I will configure and show you.